All right, we're going to finish 2.2 by integrating some relatively easy word problems. And I know that most of you might think that's not even a thing, but they're not that bad. They're easier than some that you maybe have worked with in the past. Formulas and solving equations when you have word problems involved. Okay, I'm just going to do a couple examples that are, well, 3 examples that are similar to ones that you'll have to look at in class tomorrow. And yeah, hopefully it'll be helpful. So one of them is a formula that we've seen already. It's called simple interest. And so this is P times R times T. And then what this stuff means is over here on the right. And so P is what you initially put in the bank. Okay, it's P for principal. All right, the principal is the first in charge in the school building. The principal is the first amount of money that you put into the bank or whatever. R is the interest rate. It's always advertised as a percent, like a 7% interest or 2% interest or whatever. But when you're doing the math, it's got to be as a decimal. Time, well, I'll even just come down here. On our example, we have annual interest. Okay, that's usually what it is. Time has to be at the same units of measurement as the rate. So it's 7% annual interest. Then time's got to be in years. And then int I is the amount of actual interest that is earned, so the money that you get from the investment. Okay, so I'll clone this and bring her down because the example we're going to use uses it. All right. So what is the principal if you made $75 on a? Well, okay, you guys, I'm insulting you by reading this to you, but all right, so the strategy that I always use is that even if I don't know how to do a problem right off the bat, I just start trying to figure out what number goes with what variable. Okay, we have 4 variables here, and notice there are 3 different numbers. It's amazing how often that's the case. Okay, so the principal is, well, shoot, the principal is P. So that looks like, since that's the question, P is probably the thing we don't know. Okay. Okay, and I made $75 on the investment, so the interest earned is $75. So I'm actually going to replace everything here as we go. 75. Okay, on investment with a 5% annual interest, so that's the interest rate. Okay, and so, all right, so it's 5% annual interest, so that is 0.05. So with percents, remember what you got to do. You got to move the decimal point once, twice. So it's 0.05. So it's 0.05, and this is 1.5. Okay? So now it's math time. We have to, actually let me cheat and use this. So we have to, well, I'm not ready to do that yet. So we multiply these together, and we get 0.075 times P equals 75. And we have to divide both sides by the 0.75. So divide. All right. And what happens? Well, on the right they cancel. So it's just P. And on the left, if you do the division, it actually works out to be exactly $1,000. And it's dollars because that's what's principal represents. It's the amount of money you put into the bank or whatever initially, and that's $1,000. So there you go. $1,000 invested would earn $75 in interest. So you would end up with $1,075 in the bank. The original $1,000 and then the extra $75 earned from interest. All right. So a lot of the other ones are geometry examples. And what I'll do is, no, that's not what I want. There we go. cut back and forth to the formulas. Okay, and so when we work on this in class together, I'll make the formulas available for you. So 2 examples, one where the math is not so hard, one where it's maybe a little bit trickier, and apparently it's thunderstorming. But anyway, the volume of a cardboard box is 600 cubic centimeters, blah, blah, blah. So I go back and I know I'm concerned with volume of a box. That's what's being referred to. So I better find the volume formula for a box or a rectangular solid, and it's right here. Length times width times height is volume. It's actually pretty darn similar to the formula we just worked with, just different letters. Structurally pretty much the same. Volume equals length times width times height. Okay? So we just start writing down what we're told in the problem. Okay? We start replacing the letters with what they represent. Start replacing the unknowns with what we know they are. They're not really unknowns. So the volume of the cardboard box is 600 cubic centimeters. So that's V. So volume is 600. Uh-oh. 600 equals. So the length and the width are 12 and 5. So it's 12 times 5. Let me unplug my laptop so it doesn't get fried from the lightning. And then H. H is the thing we don't know. Okay, that's the thing that's being asked. So we know we're always going to be leaving that as a variable, right, for now. But 12 is the width, 5 is the height, and then very similar to what we did just a second ago. So 600 is 12 times 5 is 60. H divided by 60, and maybe, and so we get the height is, and I haven't left room for units of measurement. So whoops, 10 is the height. 10 what? Well, everything's in centimeters, so that's got to be centimeters. All units of measurement all the units of measurement are related to centimeters. Even the volume is cubic centimeters. So there you go, 10 centimeters. So the algebra is harder in this one, so I'm going to save it for last. Height of a trapezoid is 5 meters, and one of the bases is 10 meters. All right, here we go. I'm cheating. So what's the other base? Well, this is actually the same darn example I did in yesterday's lesson, or yesterday's notes. This formula here. All right, so let me bring it up. Okay, 2 bases, we call them B1 and B2, and it actually doesn't matter which one we're going to plug into, so whatever. H and 1/2 is 1/2 obviously an area. So H is the height, A is the area, and these are the bases. So just like the other ones, we start plugging numbers in. And I guess I'll bring up, if you guys are visual, let me, here, they use different letters in my little thing. Period, trapezoid, B1, B2, the height, and then the whole shebang is the area. So the height is 5 meters. So I can just, really what I do is just start, as soon as I start getting information, I start plugging numbers in. So it's, height is 5, height is 5, 1/2, okay. One of the bases is 10 meters, so I'll just say B1 plus 10. It doesn't matter, I could do 10 plus B2, that's fine. It will work out fine either way. And then if the area is 100, that means I got to throw 100 over here, maybe, and all sorts of technical difficulties. Okay, fixed it. I just paused it and fixed it. That was frustrating. All right, so there we go. 100 goes in A for the area. 5 is the height for H, and then either one, it doesn't really matter. One of the bases is 10, and so we just solve for B1. By the way, this is remarkably similar to an example I did yesterday, and also one of the exercises that we did today in class. Yeah, so we just start doing what we need to do. So I would definitely, we have 100, might as well simplify this. This is 2.5. Okay, 5 over 2 or 2.5. You can go off the side and do whatever arithmetic you need to do. B1 plus 10. Okay, and you have 2 choices. Whatever you want to do is fine. I would say dividing by the 2.5 is a little easier. Okay, I could distribute the 2.5, and that would work too. Okay, but okay, and whatever long division you have to do, you could make everything a fraction if that you find that easier. Whatever you want to do. This cancels. Turns out this works out to be 40. Okay, 100 divided by 2.5. If you do the long division, or whatever you need to do, you'll get 40. Maybe I'll do that kind of off screen after I pause, and just so you see the work. But anyway, last but not least, we subtract 10, and so we get the base has to be 30. The other base has to be 30. I don't know what meters. Okay. Right. So there you go. The other base, one base is 10. The other base is 30, and apparently that all works out. Okay. So I'm going to pause it and throw the long division over here on the side so you see that done, but otherwise we're done. Alright, Light, I'll actually show it to you. I figured this with decimals, you probably want to see it. So, to figure out how to do this, how I do it, and I hope it's consistent with how you've seen it before, but what I do is I want everything to be, like, I don't want any decimals. So what I do is I move this over 1 and make it so that it's like really 2.5, or 25, I'm sorry. So it's really 2.5 by moving that over, or 25. Okay, but I got to do the same to this part. So this guy moves over 1, so it's boop, and then so it wasn't, we're dividing into 100, so we got to move this over 1 because I moved this over 1. And heck, can I just manually move it? Nope, I can't. It moves to the right by 1. So there you go. So I moved, the decimal was here, I move it over 1. The decimal was here, I move it over 1. That way it's 25 goes into 1,000. It'll be the same answer even though it's a different divisional problem. It's a different problem with the same answer, so it's okay. Because I'm just concerned with the answer. So 25 goes into 10, nope it doesn't. 25 goes into 100, yeah, 4 times. So we get 100. Zero times, boom. All right, 0 more times, so there we go, 40. That's how I got to 40. All done.